An invisible black hole has been detected outside of our Milky Way galaxy. A small black hole that's just hanging around, quietly minding its own business, has been detected outside the Milky Way galaxy. This, the team says, marks the first time that we've been able to conclusively detect and identify an inactive black hole that is not within the confines of our own galaxy. While a similar discovery was announced last year, evidence of this true identity left some wiggle room for doubt. This newer finding, according to the authors, is a solid bet. Admittedly, the object is not at all that far from our Milky Way galaxy. It's nestled within a satellite galaxy called the Large Magellanic Cloud, and if you are in the southern hemisphere, you can see that on a clear night. Those pink things hanging in the middle of the sky are the Large Magellanic Clouds. There's two of them. Now, the discovery is here of this little black hole is one that could help us find much more such black holes in the future, and has implications for our understanding of black hole formation to start with. The team behind the report is clearly thrilled, not least because of their skeptical reputation for casting doubt on previous dormant black hole findings. Astronomer Tomer Sharon of Amsterdam University, Netherlands, said, "For the first time, our team got together to report on a black hole discovery instead of rejecting one. We identified a needle in a haystack," he said. "Black holes are tricky little beasties," he said. "Their extreme density produces an extreme gravitational field. That means not even the light whizzing through a vacuum, the fastest anything can go in the universe, is able to achieve escape velocity. This means that they're shrouded in darkness, emitting no light that we can detect. The exception is when they are active and feeding or accreting material. This is a messy process that produces a telltale signature of X-ray radiation from the vicinity immediately around the black hole. Inactive or quiescent black holes are more or less invisible, but that pesky gravity can give it away if you know how to look. If a stellar mass black hole is in a binary system with another star, the orbital motion of the companion circling what appears to be empty space could indicate the black hole's presence. Not all dark masses are black holes, though. Other astronomers have been fooled before, the most famous example being a black hole touted as the closest yet to Earth ever found. A small, dim companion whose light cannot be discerned could be the culprit, meaning no option can be left unconsidered. Schenner and members of his team, including astronomers Karen L. Badri of the Harvard Smithsonian Center for Astrophysics and Julia Bodensteiner of European Southern Observatory, ESO, have been among those painstakingly debunking such discoveries, but that does not mean they think such black holes are not out there, just that the evidence needs to be watertight. Bodensteiner explained, "For more than 2 years now, we have been looking for such black hole binary systems. The focus of their search was the Tarantula Nebula and the Large Magellanic Cloud, a stellar nursery where young, extremely massive stars can be found. The researchers studied in detail around 1,000 of these young massive stars, looking for the telltale wobble of a binary orbit. When any two objects orbit one another, they do so around a mutual center of gravity called their barycenter. For a system like Earth and the Sun, the barycenter would be close enough to the center of the Sun that it would be hard to see the star move around it from any great distance. Were Earth more massive, the Sun's circling of the barycenter would be far easier to detect. We can detect this wobbling movement, or radial velocity, in the spectrum of light from the object as it stretches into larger, longer, redder wavelengths moving away from us and compressing into shorter, bluer wavelengths moving towards us." The team searched their sample for the spectral shifts and got a hit with a massive blue-white O-type star 25 times the mass of our Sun, around 160,000 light years away. When they calculated the mass of the object, they that could cause the observed wobble, they found that the companion was around 9 times the mass of our sun, and at that mass, the black hole's event horizon would be just around 27 kilometers or 17 miles across, that's all. And yet it was invisible. The upper mass limit for the neutron stars is around 2.3 times that of our sun, so that rules out those. Other stars in their sample that wobbled were ruled out using the team's techniques to detect light from faint companion stars and modeling the light expected from a faint companion at the observed mass. None of the alternative explanations fit the observation data. When Tomer asked me to double-check his findings, I had my doubts, El-Badri said, but I could not find a plausible explanation for the data that did not involve a black hole. The binary named VFTS 243 could hold important clues about how black holes form. Scientists believe that there are multiple scenarios. The first is a colossal supernova in which an unstable star erupts, exploding its outer material into space, while the core collapses down into a black hole born of fire and fury. The second is a direct collapse in which a dying star, no longer supported by the outward pressure supplied by atomic fusion, just collapsed in on itself, not with a bang, but with a quiet kerflump. The star that formed the black hole in VFTS 243 appears to have collapsed entirely, with no sign of a previous explosion, Shinar said. Evidence for this direct collapse scenario has been emerging recently, but our study arguably provides one of the most direct indications. This has enormous implications for the origin of black hole mergers in the cosmos, Shinar said. Although, of course, having scrutinized so many other black hole discoveries, the team now invites other astronomers to scrutinize theirs. So fair is fair. This has been published in Nature Astronomy and is by Michelle Starr and Science Alert. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.